everybody. Thanks for coming to this talk. Yeah, my name is Slim Baltaji. I'm a director of enterprise architecture at Capital One. Capital One is a financial corporation, one of the top 10 US financial corporation, and also we have offices in UK and Canada. We try to move from being a bank, traditional bank, to fintech, so it's kind of like a data engineering company. And usually people will leave this to the last slide. I would say it up front, at least to justify the $500 bill of my hotel, whatever, and my flight. Capital One is hiring. So this way I'm done with that part. Okay, so yeah, let's now let's talk business. Yeah, I have over 20 years, so also it's needed to say these couple sentences, right? Sometimes to justify who's this guy, although I already recognize a lot of faces. Yeah, I have over 20 years of experience in IT, and I spent the last 7 years focusing exclusively on big data. So when I say exclusively, I went through all the stages of being an early adopter at one of the financial corporation, another one, not Capital One. Also worked on over 15 big data projects as an architect, as an engineer. And now I continue evangelizing big data, giving talks. I enjoy giving talks. Maybe from the first slide you saw that picture of San Jose. Maybe it will be the only thing that I will know about San Jose after I leave. So that happened a few times. I was in Sao Paulo, Brazil. I was also in Dublin, Ireland. I was in Shenzhen, China, and all I will remember is just that picture. So at least I convinced myself I know something about the city in which I gave a talk. Yeah, I will say also thank you to all the people who voted for this talk. This talk won the community vote. So we did not go into politics or any other things to have this talk accepted. So that was pure work of the community. So big applause to the community and to you who are attending here. And also would like to add this disclaimer. I am not selling to you anything. I'm not affiliated to any single project, be it open source or commercial tool or anything. I'm just here to share with you some thoughts. Some of it may be correct, some of it be incorrect, and we can open it to discussion at the end of this talk and also afterwards. So that's my disclaimer. I identified the 6 big data trends. Obviously, you can identify even more, or you identify different ones. So that's based on my experience and based on actually tracking what's going on in the big data on a daily basis. Specifically during early time in the morning where my wife and kids are asleep. So that's the time where I got to understand these big data trends besides a busy schedule working as full-time. So let's start from the beginning. Maybe I go back and summarize this, the go back button. Oh, it works. So maybe quickly at least list them, and then we can go one by one. So one is about portability between big data execution engine, and we will share how many people of you, I will ask this question, suffered while trying to move from one engine to the other, especially the early adopter who adopted MapReduce. Then the emergence of stream analytics. I think today, maybe kudos to Kostas Tsuma from the Data Artisan. He gave an excellent talk, although the talk was on Flink, but he touched on this emergence of stream analytics. But you will see that I'm touching this from different angle. Also in memory analytics, people might say, why this guy is talking about in memory analytics a new trend. You will see why it's a new trend. Rapid application development of big data, yes, RAD and big data. Open sourcing machine learning system by tech giants. And the 6th one is hybrid cloud computing. So enough now for this, obviously introducing the talk, and now let's go to the meat of the subject. So I mentioned, especially those of you who are early adopter of MapReduce, and later people who adopted the Spark, and maybe recently the Brave who adopted Flink. Yeah, if you do an abstraction, and especially if you are architecture, maybe you like this diagram. It's not my diagram, but it's a diagram that I actually adopted from one of my friends who is professor actually at the university in Sweden. What I like about this one is make it easy to show like a typical big data analytics stack. So at the bottom, you have your storage layer, you have a resource management, In this case, if in the case of Hadoop, it's Yarn, right? And they have the execution engine, that's the core of your big data analytics stack. And you have either libraries or tools on top of it. So we'll go quickly through this one. So when it comes to Hadoop, you have the MapReduce as your engine. You have Yarn as a resource management. You have your database, HBase, storage, HDFS, and you have streams, Flume, whatever. You are actually, and then you have different tools. Let's say it clearly, you have different tools. Graph processing, GraphX, machine learning, Mahout or Mahout, depends how you pronounce it. Scripting language, let's say Hive Pig, application cascading, streaming Storm. And now what Spark came with, and this is excellent, actually, addition from Spark. Number one, so abstracted the resource management. So it works on Yarn or it works in Mesos. And it works even better on Mesos versus Yarn. And also it tells you I'm actually agnostic about your storage layer. Basically, bring your storage. As I live in Chicago and live in the US, many restaurants will have that sign, bring your own beverage, BioB. Here is the same thing, BioS, bring your own storage. So what else here we can tell? And the thing that Spark bring, and that's excellent too, instead of these separate tools, they became libraries on top of the same abstraction, right? RDD, and now we are moving to a different abstraction thanks to Flink. So what Flink bring here? Again, so execution engine, which is for the first time ever, and you don't have this even in the commercial space. It's an engine which is, supports both, I will say it clearly and loudly, stream and batch. That's the only tool. Correct me if I'm wrong. I will add another sentence. That's the only tool that supports real-time stream analytics plus batch and different workloads. For example, Apache Apex have this capability of supporting both real-time stream analytics and batch, but lacks the other APIs or the other library on top of it. So that's maybe differentiator here for Flink. And the stream processing in the case of Flink is not a library. It's a part of the API. So that's built in the API. That's core of the offering of Flink. So I will prefer to stop here. Otherwise, we'll turn it into Flink talk or talk about big data. So what we wanted to say from this one. If you picked the Hadoop MapReduce, and many of you did, and especially the Java Hadoop MapReduce, which looks like the assembly language of big data, and now you see the power of Spark or Flink, you might be stuck with your code. Some of your mapper and reduce, you might reuse them, if you are lucky, and otherwise you might end up rewriting your application. So that's a big challenge. You are lucky if you adopt Flink, because Flink have that Hadoop compatibility layer. But this is still kind of like beta, so it's good, the idea, but I'm not aware of its maturity. So what I'm trying to say here. And later, for example, if you are Hortonworks, and this is Hortonworks event, big event, you might be lucky that under the hood, they rewrite the code to have Hive and Pig run on Tez and boost the performance. If you are using Spark and you have legacy code, Hive or Spark, you might be hearing for maybe a couple of years now that you will have a Spark, which is Pig on Spark and still not delivered yet. You might hear that Hive on Spark is there, but if you check as a developer, if you check there is an issue, by the way, but the vendor, I won't name it, will tell you differently. Anyway, so that's kind of the challenge that we have. Now I'm seeing a pattern, and this is the pattern that I'm talking about here. Here we are seeing actually emergence of Apache Beam. What's this Apache Beam? Apache Beam is the result of many years of experience at Google. So sorry to say that Google is the god of big data. How about that? Sorry to say that. But that's the idea, you like it or not, right? So these people were early in bringing big data, and we better listen to them, and we better check what they are coming with. So after these 10 years or whatever, they are coming with this actually abstraction. Think about it like the model, right? The programming model, which is a data flow. And as a result, to make it short, now you have a single API. with which you can write batch and stream processing workflow. This is beautiful. This is a big paradigm shift. Maybe you did not hear much about it actually in the news or whatever, but for me as a technical guy who actually went through all this evolution in big data, this is very big. And if you don't see it big now, I will foresee that this will become big. And what's the idea here? It's think about it like SQL. So now it's kind of like the plain field SQL will be the common, right? Like, and then the different commercial tools or open source tools, they are actually coming with the differentiator is in the execution engine, is in the execution, not in the logic. So that's the main thing. And I foresee this happening in big data. So this becomes the data flow, the programming model, and then the different execution engine, everyone will come with its actually spices and with secret sauces. So that's kind of like what I think, and this is the big one. So as an end user, as a developer, what you gain, basically, you don't have that problem now anymore with having this type of challenges migrating from one tool to the other. For example, Apache Apex is an excellent stream analytics tool, but the API sucks. Sorry to say that. I have friends that are working on that. But now they are smart enough to consider having a runner, right? Using this Apache Beam, now you have all the goodies that they have, and plus this excellent API, unified API, and that helps, right? So this is an example. That was my first one, and about portability between big data execution engine. So here, maybe key takeaway here, watch out this project and adopt it, and if you can contribute to it. If you don't see it that big now, we'll remember you say the guy actually wearing glasses, actually a bald guy, right, from Capital One said it in the Hadoop Summit that this is big. So second thing is emergence of stream analytics. Yeah, what I mean here, so there is a famous professor, right? His name is Stonebreaker and all. We have a lot of respect for this professor. He's already predicted in 2005 that stream processing will become increasingly important, right? And he attributed this to the sensorization of the real world. This is his wordings. Everything of material significance on the planet gets sensor tagged and report its state or location in real time. And we have the paper, academic paper, the link to it. Yeah, I think he's missing the point. What does it mean he's missing the point? Yeah, as we can see here, stream analytics, stream processing is becoming not only important, not only because of the sensorization, you will see this is a tiny aspect, but because of many other reasons. Actually, Kostas Tsoumas from Data Artisan touches on this one point, which was actually that everything is a data stream and the nature, but this is also, again, one aspect. So again, they are missing a few other reasons. Let's check them one by one. So this is a simple diagram, a simplistic one. So reminding you that there is 4 reasons for the emergence of stream analytics. Now check them one by one. So what you are seeing here, real-world data is available as series of events that are continuously produced by a variety of application and disparate systems inside and outside of the enterprise. So example, sensor networks data. So you see, this is only one piece, one category. What else? Web logs, database transactions, system logs, tweets and social media data, click streams, mobile apps data, and you continue. This is all data streams. Basically, every data which is being produced is a data stream. Nobody dumps on you 1 terabyte of data. If somebody ever did that, so there is something wrong, right? So how about the second factor? Okay, so it's about technology. There is a very important thing here, simplified data architecture with Apache Kafka. I think without Apache Kafka, we won't see this emergence of stream analytics. I think this is the backbone of stream architecture. So that's number one. The other thing, you have now a variety, and even this becomes even crowded. So let's name a few of open source stream analytics tools. Apache Flink, obviously, that's my preferred one. Apache Apex, Spark Streaming, Kafka Streams, Apache Samza, Apache Storm, Apache Gearpump, Heron, and you continue. So the list is endless. So this is also second factor. Cloud services for stream processing. You can tell that the giant, they are also getting into this business. Google Cloud, they have their own offering. Google Cloud Data Flow. Microsoft also, they have their own offering. Azure Stream Analytics. Amazon, they have their own offering. Kinesis Streams. IBM also, they have InfoStream streams. So this, while you're analyzing this trend, you can tell this is not just about the technology, but you can tell that this company, they have their strategies and they know what they are talking about. There is also many vendors. This is not an exhaustive list. Confluent, Data Artisan, Databricks, MapR, Hortonworks, StreamSets. Sorry for Cloudera, they are not listed here. I don't see they are actually innovating when it comes to stream processing, and I have nothing against this particular vendor. I worked for Hortonworks in the past, but I'm free now. I don't work for any vendor. Okay. What else? More mobile devices than human beings. So it's not about the number. It's about the quantity of data that's being generated and the application that are going. This is really crazy, actually. This is true statistics. In the US, there is more mobile application than the US population. The next thing is the business. So the challenges. There is a lag between the data creation and the actionable insights. This is well known, actually. The other thing, infrastructure is idle most of the time. Obviously, if you do it the retarded way, sorry, the batch way, what does this mean? So you just sleep all the time, and you wake up at the end of the day, right? At the end of the business day, and you do some of the processing. And you struggle to finish this before 6 a.m., whatever, because you need to have these reports for the big bosses. And meanwhile, during the entire day, almost, your infrastructure is idle. I don't think this is smart. What else? Web and mobile application growth, so that there are, as we maybe touched on this, when it comes also to saying there is a lot of mobile application, need of organization to shift from reactive approach to proactive approach. What does this mean? Reactive approach, you analyze things after the fact, right? Proactive approach, before even things happen. So that's kind of like the trends. What are the opportunities? So if you embrace stream analytics, you can gain faster time to insights, competitive advantage, and operational efficiency, as we named it in relation to our infrastructure being idle. With stream analytics, new startups are or will be challenging established company. This is very important. So this technology, if you are smart enough to have a business idea, you can go challenge, let's say, for example, insurance. You have insurance companies which are there for more than 100 years. And now a small company with less than 10, I won't give the name, less than 10 employees, they are disrupting that. They are coming with pay-as-you-go insurance. So if you are basically somebody who is driving his car only during the weekend, why you pay that 600 every 6 months or whatever? That's nonsense, right? So now they are disrupting that market. Now we can say that speed is said to have become the new currency of business. How about the consumer? So what does this mean? So now you are interacting with your Twitter, with LinkedIn, with your Facebook. And now in your behavior, you become somebody who expects to have things instantly, that instant gratification. You don't have control on that. Now, you are as the same person when you are dealing with a business application, you expect the same. How about the kids who grow up playing actually video games, and now they are growing up, including mine? They don't want to wait. So that's the thing. Now, what we are saying here, combined, the four things combined actually explain somehow the emergence of stream analytics. And the idea here is this is not related to a specific industry vertical. Maybe I can have another talk, another year, actually. Yeah, where actually I researched the different verticals, you name it, financial service, telecommunication, online. Originally, the stream analytics was only confined to a couple verticals, the financial service and the telecommunication. The financial services, few well-known use case, telecommunication like also in the ad serving. Not anymore now. The sensor network, social media, healthcare, oil and gas, whatever. There is a lot actually of verticals who can benefit from stream analytics. Here, a high level of solution architecture of end-to-end stream analytics. Not much different from anybody who will show you that. So we have three main sections: the source and integration, analytics and processing, serving and consuming. I just put here some little more details here. So that's for your own convenience. Take a look. I think every single application, you can map it to this one. You might not have all the pieces for your own use case, but everything I think is covered here. Or you might have a bidirectional arrow if needed. So that was the second one about emergence of stream analytics. How about in-memory analytics? Somebody will say this is not new. I agree. But what's the trend here is that it's getting renewed attention. Based on what? But there is actually now in hardware, there is new memory, right? I won't actually advertise a specific vendor in the cloud, but you will get shocked when you hear the type of instances they are providing when it comes actually to memory available, right? So take this into consideration. Also, the maturity of newly available in-memory open source. So I categorize them into 4 or 5. Memory-centric distributed file system, columnar data format, key-value data store, in-memory data grids, distributed cache, whatever. Let's give a couple examples. So these are not exhaustive, right? Luxio, watch out this one, actually. So it used to be known as Tachyon, one of the very fast, actually, growing big data open source ever. Maybe couple usage pattern here, not exhaustively. You can accelerate your big data analytics workloads by prefetching views and creating caches on demand. And something even more important is that you can share your data between your application. Wonderful type of use case. RocksDB. This is this rocks. So how about that? Yeah. So this is an open source library from Facebook that provides an embeddable, persistent key value store. It's used by Samza, by Flink, by Kafka streams. So this is also a wonderful tool. So you might have use case when you need to use it. What else? Apache Arrow. This is also something to watch out. What was my promise here? We are analyzing the trends, but also giving an example from the open source space. So this is a columnar in-memory analytics. Have a lot of advantages. And basically here you are seeing that unification in many layers in big data. Be it the storage layer, be it whatever the processing engine. Here we are seeing unification when it comes to the memory format. So this is something worth also noticing. Now we have 18 minutes. I think it will be, I will try to speed up a little bit so we can open it up to a few questions. Rapid application development of big data. Yeah, definitely we can say that. So there is many aspects that can actually explain this rapid application development of big data. The APIs, notebooks or shells, the GUI, and the microservices. The APIs, I think we touched on that, right? So obviously, no need to say that Apache Flink, Apache Spark, they make actually our life easier compared to Hadoop, MapReduce, whatever, and Apache Beam now is taking it to another level by unifying the batch and the stream API and allowing this portability that was our first one. What we are actually trying to say here, more than the API, now you can use notebooks. Maybe you might have a specific talk here about one of these notebooks. So basically, compared to the era of Hadoop, you can actually build your application in a rapid way. This is an example from my own laptop. So that was using Apache Flink on Apache Zeppelin. That's good actually to do this interactive type of programming. That's wonderful. The GUI, Apache NiFi, I think this is an excellent tool. Maybe there is, not maybe, I think there is a tool also, there is a talk about this tool worth actually checking. See, this is when we are saying a trend. So many actually factors that are participating in this trend. For those of you who joined the big data actually wagon recently, they might not suffer as those who suffer early when you use it to write plain Java Hadoop MapReduce. So now for ingestion, it's a couple of clicks, and here we go. You have a pipeline to ingest your data. Wonderful type of things you cannot dream about before. How about microservice? This was touched a little bit in the previous talk. But I think this is also very important now from developer perspective. So now this trend, what does this mean actually? Especially if you are using Kafka as a major part of your data flow, you can actually build microservices. And from developer perspective, so you have small teams and cross-functional teams who can leverage this type of architecture. Now, another trend, and this is really amazing. Actually, I gave this talk privately in a big data corporation some time ago, and I got the feedback that how did you gather these different open source machine learning from tech giant. Watch out this one. Facebook, they actually contributed to Torch. IBM, they open sourced their system ML. Google, they open sourced their TensorFlow. Microsoft, they open sourced their tool, the MTK. We will go through details. Yahoo, they worked on Cafe. They make it work on Spark, and they open source it. Amazon, more recently, they open sourced their tool. You can read that as Destiny, although DSSTNE, whatever. That's crazy, right? So these are big data giants. And all of them, all of a sudden, they wake almost at the same time. You'll see the date. And they decided, how about we open source our machine learning tools? There is something going on. I won't say fishy here, no, in a good way. Yeah, exactly. In a good way that this company are seeing this from a strategy perspective. So that's something happening. Let's see into more details, actually. Torch is, it's kind of like one of the oldest open source machine learning library. But what Facebook added to it, they added a deep learning library. And now watch out exactly what is being added or what they are working on. So follow with me now when it comes to Facebook. They added algorithm focusing on deep learning. Apache System ML, for example, in Flink, in Spark ML or MLlib or Flink ML, you don't have, correct me if I'm wrong, you are more expert, support for deep learning. So this tool, Apache System ML, which came from IBM, do support this type of machine learning. So that was open source on November 2nd. Even check the dates. TensorFlow, also one of its major, it's a big things, but one of the major things, it's a support for deep learning. That was open source on November 9th, like 7 days after. I don't think actually this is a pure coincidence, even when it comes to the dates. 1 week later. 1 week later, what happened? 1 week later, Microsoft also open sourced their tool, Distributed Machine Learning Toolkit. Little bit later, now that was the end of 2015, towards the end, but early in 2016, I did not follow later. Maybe things are happening again with other major company doing the same, with Yahoo, open sourcing Cafe on Spark, and with Amazon, open sourcing their Destiny tool. So what's happening? I think this is really, again, here, let's say, a paradigm shift or a big moment to stop and to think about. What's the trend here? Similar to what you have in big data, that's a point in time when big data became kind of like a part of everybody, actually not just a buzzword, but also later as a part of the strategy of every single corporation. I foresee this is happening with machine learning and the subset of machine learning, which is deep learning. So this is what I'm seeing here. And what we will see, I will say it one more time, you will see disruption of many industries with these powerful tools. If you check, for example, the TensorFlow, what is doing, it's crazy the type of things that we are doing. I don't have this in my slides, but I also was tracking the company who are jumping on this opportunity. So there is a lot of startup popping out from nowhere, and they are also coming with a new application. So that's kind of like a major trend here. So let's summarize it. So the big data giant, not big data necessarily, data tech giant company, they are open sourcing their machine learning tools with a focus on deep learning. We are seeing many, and they are with the goal of disrupting many actually verticals, very industries, and a lot of startups. I have a list, but I don't have it in my slides here. In no time actually jumping on this opportunity and already using these tools. So this is, I think, one of the major trends. And what we are seeing here, not just the open source, but this combined with cloud, or combined also with cheaper now commodity cluster. So we will be seeing a lot of disruption. What is my last trend? So this is, I call it hybrid cloud computing. Maybe not a secret here, this is public information. I work for Capital One. and Capital One Financial Corporation make it big. I know there is few people from Capital One here in the room, but I'm sharing public information. So by 2020, no data center, no on-premise. Isn't it crazy? So that's exactly the vision of Capital One. Do not have a single data center on-premise. But as we are moving towards that vision, we are actually discovering that this is a great vision, right? But at the same time, to implement it, you cannot avoid having like a hybrid model. When you have part of it in your own data center and part of it of the cloud. Are we having that maturity that everything can move to the cloud? I think we are not there yet, but that's in case of Capital One, that's a vision. The technology is maturing very fast. So what we are trying to say here, there is different pattern actually here. And maybe here I'm not that expert on explaining it how, but maybe open it up for instead of a question, somebody can contribute. So that's kind of like another pattern when you see actually dependent on your case, how you can have your deployment as a hybrid on the cloud and on-premise. A couple examples here. For example, let's say you have data which is from SaaS, software as a service application. So I don't want to name a commercial one here, but there is plenty of them, let's say for HR. And then you need that data to integrate it or to do some advanced analytics with your data that you have on premise. This is an example model when you cannot say, actually, I move everything to the cloud. Another example, how about your data warehouse? So you might, for cost efficiency, push some of the data to the cloud. How about here your stream analytics? Maybe in your case, you have such very low latency when it comes to requirement, and you cannot afford to just go to the cloud and do your computation on the cloud. So this is kind of like food for thought, as they say. Here, maybe this is only couple actually pattern, but obviously, if this can be a separate talk in itself, when we can analyze actually the when and the how actually it comes to deploying your big data application. What I'm saying here, the model I'm saying more like a hybrid cloud computing model, more than everything goes to the cloud. It's a case by case. So what are a few key takeaways? So my takeaways might be different from yours, but at least let me share with you what I think, like something if now I play a different role, if I was one of the attendees, what I will take from this talk. Yeah, one is, this is a call for adopting Apache Flame, Beam. So what I mean here, call, just watch out this project, and obviously the first version 0.1 was just released on June 15. But don't get me wrong here, the tool is very mature. Don't get stuck with the versioning, because that's the work of Google for many years, but it's just a matter now of packing it and following the Apache foundation type of structure when it comes to the code. Second one, adopt stream analytics for faster time to insight, competitive advantage, and operational efficiency. I think this is a trend, and as we are actually seeing more maturity from these open source tools, and as we saw the combination of the different factors, we will see this taking over batch analytics. It doesn't mean that batch will die, but more and more we'll see stream analytics taking over. Third one, accelerate your big data application with in-memory open source tools. You might have already an application where you are seeing some slow, or you might boost the performance. You have now few open source tools that can help you boost dramatically this. Let's say, for example, you are doing even something like BI or whatever, by just having a layer that allocs you, right, before you query the data. And here we go now. It boosts dramatically the performance of your queries. Rapid application development. Those who are actually joining the big data wagon now, they are very lucky. There is a lot of tools available. I mentioned a few of them, Apache Zeppelin, Apache NiFi, just to name a few. machine learning. So this will become actually very big. So, and I foresee this is becoming part of every company strategy. The major challenge here is the skills sets of people. So that's many people, unfortunately, all of a sudden they turn from being business analysts, all of a sudden now they have data scientist on their resume, whatever. It doesn't work like that. So, yeah, sorry to say that. So that's the challenge is in the skill sets. But I think with the open source tools that came from this tech giant with this push, I think we will see this mainstream. The last one, I leave it as a question. So how to advance your strategy for hybrid integration? Maybe I can do more homework and came later with a full talk about that, the pro and cons and the use case. We have 5 minutes for a question. It doesn't need to be a question. You can also add if I missed something or if I did something wrong, correct me, please. And that's about it. Yes, please. Yeah, a question or comment or something. Maybe somebody thinks also about another trend. Yes, please.
Slim, do you think that when you're talking about hybrid cloud environment,
yes.
Do you think that hybrid cloud will also include the pervasiveness of the EDW on-prem or in the data center to be included in this type of analytics?
Yes, I think so. Yeah, I think so. It's actually one of the pattern, actually. Yeah. Yeah, any other question, please? Yes, please. Yeah, actually, I think there is a, I'm not 100% sure, but I think there is a couple open source tools when you can actually have an abstraction layer on top of, whatever cloud. So this way you are not stuck with a specific vendor. Yeah, I forget the name. I think it came from, during the time when I was focusing on Spring framework. I think, I need to double check. Yeah, I think there is a layer. It can shield you from being stuck with one particular vendor. Excellent question, by the way. Yeah. Yes, please.
Have you seen any applications for statistical sampling to speed time to decision making, as opposed to just processing more and more data all the time?
Yeah, I'm not sure I got your question right. Yes, please. Can you give us concrete? Yes, please.
So, are you seeing any applications for statistical sampling of data to reach conclusions rather than processing all the data all the time in real time?
Yeah, I think so. I think this is one of the trends. Yes, indeed. Yeah. Yeah, indeed. Yes. Yes. Yeah. Yeah, I think now we have sophisticated algorithms which can allow you to do that, actually. Yeah, and if I'm not mistaken, deep learning is in this type of algorithm. It's in this trend. You don't need to process all the data. So that's basically it. Yeah. Yes, please. Any other question? We still have a couple minutes. Yes, please. Maybe also somebody to comment to say, you know what, you missed this trend. How about hardware or something? Yes, please. Yes, please. I think it depends on your data, right? And I think it's kind of like we are a bank, right? So we care a lot about security. But there is a way to fix it. And also, when you say hybrid, you can have a private cloud. So let's say I don't want to name a particular vendor, but what you call VPC, right? Virtual private. So that's cloud. So that's, there are solutions for that, yeah. And when you hear that the CIA, actually, they have a lot of their data in the cloud, you don't get, you understand that security is not a major challenge anymore. Yes, please. Yes, please.
So, being the capital of a financial company, right? So, how do you take care of your PII data? What kind of, do you use any tool or any other product to enable the encryption and tokenization and detokenization of the data?
Yeah, that's why actually at the introduction of my talk, right? And to justify my 400 bills a night for the hotel. We are hiring, right, I said. Yeah, actually, we have an army of engineers now. We are hiring maybe, hundreds, actually. And we are doing some of the things custom, yeah. So not necessarily everything you can go and buy from the shelves, and that's our vision, unfortunately, right? Traditionally, a bank will go and buy something, a tool, a software from the shelves, and most of the time doesn't actually fulfill all your requirement. Now with our vision, or the vision of the CEU to move everything to the cloud, we are seeing a lot of challenges, and we are fixing many of these challenges internally. So we noticed that we can do innovation only with our own people, not outsourcing, not using things from the shelves. And it works so far. Yes, please. Exactly.
So that's a question. So are you going to follow the lead of Google and all these companies and make it open source again?
Yes, indeed. Actually, we already leading a couple open source tools, and I think even one of my colleagues here, actually, I think he works on one open source tool, and he make it, yeah. Short answer, yes. We are open sourcing. That's strange, right, from a bank. Yeah, we are doing that. An example of an open source tool that we are working on is API GUI on cascading. We are working on that. Yes, so the time is up, and the slides will be available tonight. Obviously, the video will be available from the organizer, but the slides for all of you will be available tonight. Thanks a lot for coming. Thank you.